I don't need that. Hello, everybody. A warm welcome. If it's outside weather is not warm enough, but warm welcome to Linaro Connect and to the beautiful Bangkok. As many of you know that we are going to spend this week together chatting, eating, drinking, and some people might be hacking, and others might be scheming and plotting, but all for the benefit, the good course of accelerating the deployment of the ARM ecosystem. So I'm sure Bangkok is a beautiful city, but many of you have been to many Linaro Connect, and I'm sure that Bangkok is one of the attractions for you to come all the way here, but it's not the main reason. The main reason you are here, and we are all here, is because Linaro matters. And let me explain what I mean by that. If you go back to the time that when Linaro was started, a number of people and companies within the ARM ecosystem decided and recognized that they have a set of common problems that they need to solve. And the better way to solve that is to come together and create a Linaro platform where people can collaborate, share ideas, and work on common code, and make sure that products, technologies and products upstream and downstream have higher quality, and we reduce fragmentation and increase standardization, and make sure that member companies could bring their products faster to market. And that's what I mean by Linaro matters. And if you fast forward to today, the world has changed. Many of the problems, the technical problems that Linaro was starting to tackle have more or less been solved to a large extent. Work still continues, but the world has changed, right? And in this new world, I think Linaro matters even more, because if you look at the ARM ecosystem today, it's much bigger than before because of new stuff that ARM has been putting out. The new areas that we're interested in, like IoT, auto, AI, just to name a few. And because the ARM ecosystem has gotten much larger and entirely new players coming into the field, right? If you roll back the time 10 years, you would never imagine a traditionally pure software company would start to think about doing their own SoC and work on hardware, right? So the whole world is changing, and I think that's where it makes it even more important for people to keep working together, right? And that's why I think Linaro even matters more. So I would like to have a small ask for all of you here, is that after Linaro Connect, I'd like you to go back to your company and within the next quarter, 3 months, talk to 10 people inside your company, explain to them what Linaro is, how Linaro works, and why Linaro is beneficial to your work and to your company. And also within that quarter, I hope you can talk to 10 people outside your company, explain to them the same. And I hope to check on your homework at the next Connect, which is in San Diego towards the end of the year. So ARM ecosystem has been continuously evolving, and by bringing more people and more companies into the collaborative platform that is Linaro, together we can deliver better results into the ARM ecosystem, and we can bring better benefit to our members' companies. Once again, a warm welcome to Linaro Connect, and I hope you enjoy this week. Thank you. And now I want to bring up David Rusling, our CTO, to do the real keynote. I'm just warming up.
Ha! Thank you. Thank you very much. Hi, guys. Come on, it's Monday. Thank you, thank you. I'm David Rusling, and I do software. Oops. So actually, welcome to Lee, and thanks for doing that. I've had a long and some would say fairly illustrious career. I'm in the twilight, the autumn of my career, but still I go on. Li's actually the first completely software person I've ever worked for, which is good. It's a really good thing. So a little bit, the TSC focus this week is that it's a little dull and boring, and if you're not into committees, but the plan of record, which is basically setting what we're going to do for the next 6 months. So it's pretty important to come out of that. And I'm going to talk a little bit about some of the things that kind of caught my eye about the agenda in the committee in the sessions this week. So, okay. I'll just pick one or two bits out, but the CoreSight framework. So CoreSight is a debug architecture that's alongside the main ARM architecture, and Mathieu's made great strides in actually getting that into the Linux kernel, getting it supported in a more coherent way across many devices. So that's always excellent. Bunch of work around CLang on the kernel that's really important for that long-term stuff. QEMU's got a whole much better Cortex-M support, which is good. QEMU's been really important over the years, so that's really worked out well. And Lava's embracing some of the isolation technology like Docker, which helps us do better testing. So good technical stuff, and no doubt there will be sessions. I think every second button press works. No? Security. So of late, there have been issues in security, and it's all mostly so far caused by speculation hardware, over-speculating or at least leaking speculation between states. And I think that's an area of computer architecture that's going to get very interesting over the next little while, as a very simple security model of system versus user is just not enough. And if you think about your own personal life, then your security model is more sophisticated. I may tell my mother certain things, and she won't tell my sisters. I may tell one sister something else, she may not tell the other one. So, we all have sophisticated trust models. And the hardware will do that. But mostly, I think that's a software problem. It's writing a bunch of software that understands where secrets are kept and knows how to keep them. And I also think that governments will start to legislate on this sort of stuff because it's really important. Artificial intelligence. Now, I had a slightly more interesting slide than this. But basically, AI is big news. It's in everything. All the startups are putting AI in there as technology because it's groovy and it's solving all the world's problems and life will be much better. Coming from a background of programmatic computing, it's interesting because it's data-driven. You don't always know how the results are, and it's very related to the training data. And you've all read articles that show, you get the wrong training data involved, you get some very interesting results. But really, for me, there's two parts to it. One is the kind of general device that can decide at runtime kind of which technology to use to most efficiently run the graph parsing and runtime stuff. So the other side of this is very constrained devices. So everything's going to have AI in it, right? It's all going to have machine learning in. And so it's a question of how do you do that efficiently? And in the context of the ARM architecture, that means that you're going to have a lot of devices from a lot of companies, all slightly different, all with different hardware acceleration. And you want that all to work together from end to end. Got it. Yeah, so there's a bunch of discussions this week. I think we've been working on AI for a little while. One of the interesting pieces of news is ARM-NN is now hosted on ML Platform, and there's a bunch of work that's been going on around the CI loop. And the scope of this is across all of the ARM architecture, M, A, and R. It's a secure world after all. So obviously the data center with its boot architecture thinks about security from the boot upwards and from over-the-air updates. As John likes to say, where is John? There's John, yeah, thank you. Servers are getting boring, and I'm really hoping that, you know, edge devices are going to get boring too, and, you know, it'll all work. Yeah, so there's a bunch of ecosystem developments and stuff around big data. So all that's moving on and maturing, and we've been going at this for a while, and you can see ARM in the data center and ARM especially in HPC happening. I don't think my thumb's working this device properly. Yeah, there we go. There's a little bit of a theme, although I wouldn't overplay it, around developing for ARM on ARM. And the most natural place for this is in the data center. This is just naturally the place where that's always the case, which is good. HPC, I rather like HPC because it's a really complex build-it-yourself environment. And the people I talk to around HPC are always really interesting, doing very, very exciting things in computing, like modeling the few nanoseconds after a nuclear explosion or something. So it's really technically interesting. So, I think I've talked about this before. There's a bunch of technologies that kind of originate in the data center and the small services, which are all about isolation. And there's the constant battle between, you know, all the world's problems around isolation are going to be fixed by containers, or they're going to be fixed by virtualization. Yes, I can guarantee that both those technologies will be in there, and they'll be mixed in different ways in different market segments. So that makes, you know, it makes supporting the ARM ecosystem more interesting. And as I said before, it's really a software problem. The world, you know, silicon is interesting and sexy, and you can sell it, but actually all the heavy lifting and the work is done by software. I would say that, obviously, but the interesting stuff is in the software. So, but it will vary by market. AI, I say, sexy new thing. So in the data center, AI is where the training and the heavy lifting, the graph compilation happens. So there it's about getting the workload right, measuring things, getting things tuned, being able to take advantage of whatever hardware acceleration you've got there to do the best job you can in an efficient way. Right, edge. AI is kind of the big new sexy thing, and edge is it's going to be sexy. It's all a bit foggy. This thing here, I don't know if anyone's seen this. This is a piece of data center wrapped in a piece of submarine, effectively. This is a Microsoft thing, dropped in the sea off the coast of Scotland by the Isle of Harris. Now, if you ever get a chance to go to the Isle of Harris, go, because it's an amazing place. You can get bitten by insects for the whole summer, but it is an amazing place. So this thing has been dropped. It's underwater, so it's being cooled. And there was some talk about using wave power to power it. It hasn't got arms in, by the way. But there's the point about this is there's a lot of discussion of what is edge. Now, if you're a data center person, edge is the data center transplanted, which is what this is. But actually, maybe edge is something else. And you're starting to see the terminologies like far edge, near edge, middle edge, edge. Yeah, so if you want to learn a whole bunch of terminology, this thing. What edge really is, in my view, at the moment, our computing world, my personal interaction with IoT and with the world from a compute point of view, in my house, I think the last time I talked, had about 18 things in my house connected to my Wi-Fi. I've got 42 now, including my robot vacuum cleaner. So at the moment, all of those things interact with the cloud, wherever the cloud is. You know, wherever Nest's cloud is, wherever Roomba's cloud is, whoever's cloud is, your car's cloud. And edge is really about moving data processing and compute and security out into the wild, in your car, in the bus, in the building, in your house, in your doctors, in the hospitals, you know, everywhere. And that makes things much more interesting and difficult. So I love Laurel and Hardy, and if any of you haven't seen the film yet with Steve in it, it's a really good film. So on the edge, so you get the notion of like insurance companies running applications on your device, monitoring what you're doing as part of the service they're offering. You know, or one scenario I really like the idea is you go to a baseball game, obviously the Red Sox, because that's the only team to support. Yes. Yay, Red Sox! Yeah, thank you. I've been twice, so I'm a regular about every 20 years. So the idea there is you've got your device, your phone, your whatever, and everybody's running an app. And so you can, you know, all wave your phones in the air and it'll do patterns and join in and it'll know how long the queues for the toilets are and, you know, make sure more hamburgers come down your row and your life will be better. You'll be able to buy more things more quickly and be a better consumer. It's going to be great. So a little bit of technology. The group Ledge has been going for about a year. It's a SIG. And really, it spent that year kind of honing in on what it's going to be doing with itself. So obviously, you've got things like time-sensitive networking. There's a huge thing, a huge area of problem is the provisioning and orchestration of things. So right now, my model for something is if I want to upgrade the firmware on my vacuum cleaner, it's a bit of a faff, right? So my vacuum cleaner should be getting its upgrades overnight the same way that my little Debian NAS box does, right? So there's a whole provisioning and orchestration thing. How do you manage these things? There's a whole security thing. How do I know that that sensor in my factory is trustworthy today, this instant? It's not been hijacked or compromised. So there's a whole part of provisioning that's kind of interesting. And underneath all of this, you need boot architecture to drive that over-the-air updates and validating and rolling back and, you know, all of that good stuff. I think reference platforms are kind of the key here because you're building together lots of systems and its complexity. A bit more detail. There's a bunch of work already happening from the existing members of Ledge, and there's, you know, more will happen over time. And obviously, AI is in there as well, because from what I'm reading, you can't manage any of this without AI. It's not about, you know, Frank, the IT guy, going and updating New York City's mesh network of IoT devices that's controlling all the traffic, right? So these things have got to be kind of self-reacting and analyzing and work, particularly security and stuff. Light, if you remember, is the group that's down at the device end of things. And maybe really the device is all about the edge, because the edge gateways will be controlling the devices. They're looking after the devices. That's the edge of trust, actually, as well as the edge of computing. But on the device side, there's been lots of work going on with Zephyr. I think it's pretty much at an LTS release. And really, we're starting to think about where do we go next with this? So there's a bunch of ideas, and there'll be a bunch of discussions around that. I want to say a little bit about platforms. So the thing about the ARM ecosystem that's really good is that the IP licensing model means that companies try lots of different ways of doing things. So you get, in parallel, rapid evolution of things. Open source allows you to do this because you can support anything because you can change the code. So you don't have to have a deal with Google, you just use the code, right? This generates fragmentation as a side effect, but that's fine. And when we talk about ARM and when we think about engineering, we can moan and complain about this. But that platform fragmentation also happens on other architectures that will remain nameless, because I only work on architectures beginning with A, if you remember. So this is a Chromebook. And I recently had one Chromebook, I cracked the screen, so I had to buy a replacement to come here. And on my new Chromebook, which is running the same architecture as my old Chromebook, which is now being repaired, these three things, Prime Video, Kindle, and Sonos, stopped working. Mysteriously, and it's all to do with differences in the processor. Maybe there's a difference in the platform. So it's not, you know, it's not a unique problem. And again, reference platforms will help. So part of the reason for choosing that set of things to talk about, it's interesting, is for me, is kind of trying to answer the question, what makes a good Linaro problem? Because you don't solve everything in Linaro, but there's a bunch of things that it's a particularly good place. So obviously, hardware architectures and acceleration hardware and then, all that stuff. It's good if it's involved around that, and that's where the machine learning stuff comes in, because you've got a problem that's scaling in 2 dimensions. You've got fantastic amounts of new software and frameworks for doing machine learning, and you've got fantastic amounts of hardware platforms and acceleration techniques, and so you've got an NP-complete problem if you're not careful. Another good area is key software components that SOC guys need to support, and that's the fragmentation and the platform. And quite often where it makes sense in Linaro, is around putting frameworks in place that allows you to do hardware acceleration. Another interesting area, and you can see this has happened in the data center group, is where the ARM ecosystem is going into a new market. And there's a lot of learning going on. There's a good meeting point for doing that as they come together and solve problems together. And the other side of that is where a market is getting a lot of ARM coming into it, and it's very difficult to, kind of grok what's going on. I liken it to, you're used to playing football against a team. England has a rather good football team at the moment. It's looking good. You're used to playing 11 players, and then the ARM team comes on, and it's 110, right? So it's a big, more complex problem. So those all make good things. Right, that's enough of me. Well, it isn't, but it's enough of me giving a keynote. So I'll hand back to Joe, and we can sort of finish off. So we're going to do the photographs. If you're on a committee or attend a committee, Linaro or committee person, stay for the second part. But back to Joe. Thank you.
Thanks very much, Dave.
Don't forget my laptop.